Welcome back. Today we're going to be exploring 2.4 unknown angle proofs. You're going to need your booklet, a ruler, a erasable pen and pencil, and then your sharp deductive mind. The idea of a proof is that if you accept one set of facts, then you and the concept known as deduction or one fact leading to the next, you have to accept all the consequences of the fact. Anything important, repeat 3 times. To accept a set of facts is to accept all their consequences. To accept a set of facts is to accept all their consequences. To accept a set of facts is to accept all their consequences. Now, let's talk about what that means in the very cerebral world of mathematics. Unknown angle proofs. Suppose that we already know that the angles of a triangle add up to 180. Given this labeled diagram to the right, we know that, well, can we prove that x plus y equals z? That idea we finished last lecture on. In other words, that the exterior angle of a triangle, C in this case, is equal to the sum of the measures of the 2 opposite interior triangles. Now, we label this angle W, and we're going to step by step prove that this must be the case. So the first thing we're going to do is we're going to say something we know is true, that the measure of angle x plus the measure of angle y plus the measure of angle w is equal to 180. And we're going to give a reason for that. And then step by step we're going to prove that these 3 little dots, therefore x, measure of angle x plus measure of angle y equals measure of angle z. So that if you accept that the sum of the 3 angles of a triangle equals 180 degrees, you must also accept as a consequence that the sum of the 2 interior remote angles is equal to the exterior angle, or that the exterior angle equals the sum of the measure of the opposite interior angles. So let's see how this fact, by deduction, necessarily leads to this fact. So first we're saying that the 3 angles add to 180 degrees. Don't get too lost in the notation or the language. We're working on this almost as the outline of essays that we will later write. We can then say in turn that the measure of angle W and the measure of angle Z have to equal 180 as well, because linear pairs form supplementary angles. Lastly, we say since both of these are equal to 180, we can in turn substitute one for the other, saying that the measure of the 3 angles of the triangle must be equal to the measures of these 2 angles added together, the linear pair. Well, if you notice, there's something the same on both sides of that equation, which we can just take away, in turn leaving what's left over, the 2 measures of the 2 remote angles, equal to the exterior angle. Notice, each step in the proof was justified by previously known or demonstrated fact. We end up with a newly proven fact, that is, an exterior of an angle is the sum of 2 measures of the opposite interior angles of the triangle. This ability to identify the steps used to reach a conclusion based on known facts is known as deductive reasoning, the type made famous by Sherlock Holmes to accurately describe the doctor's attack in the video clip. You know that the angles on a line sum to 180. So let's explore some of these ideas in context. We want to prove this idea that we were using, that vertical angles are congruent, using that fact we prove. So let's start laying out the facts as we know them. What do we know about W and X, Y and X? So we know that angle W and angle X are a linear pair. Take your time, don't rush in this. Better to get it fully developed and thought out than to kind of just sketch out an idea. What conclusion can we write based on both pieces of knowledge? Well, if both of these are linear pairs, then both of them. So I have to apologize for a moment. My video cut out. So let me tell you everything that I did while the video was cut out. We were just saying that these 2, W and X and Y, sum to a linear pair. So if I were to think about this informally, I say, well, if these 2 add up to 180 and these 2 add up to 180, and they both use the same thing to get to 180, therefore they must be the same themselves. But let's write that out more formally. We could then say in turn that the measure of angle W plus the measure of angle X must be the same as the measure of angle Y plus the measure of angle X, as we say right there. Now, writing out a proof means we need to make two statements. We need to rank each statement that we're making, and then we have to give a reason for each statement we're making. So my first two statements, you can call this my one, and I'm going to make these two statements for the same reason, is that in very formal terms, the measure of angle W plus the measure of angle X has to be 180. And the measure of angle Y plus the measure of angle X has to be 180. My reason for saying so is that they're both linear pairs and therefore supplementary. I can then say in turn, too, that since they're equal to each other, equal to 180, they must be equal to each other. This concept is a substitution property. I could also write the phrase, if they're equal to the same thing, they must be equal to each other. And that right there is also acceptable. Over time, you'll get used to the formal language of this, but be comfortable using your own words to explain your ideas. Then in turn, I can take away the same amount for both sides. In this case, it happens to be the measure of angle X is the same on both sides. And therefore, the measure of angle W has to be equal to the measure of angle Y, or the subtraction property of equality. What we're going to do next, now, let's take a look at something we can prove. Right here, given the diagram to the right, prove that the measure of angle W is equal to the sum of measure of angle Y and Z. If we think about planning how that works, well, we notice that angle X and Y are vertical angles and therefore congruent. So we can then say, well, let's see. We can say that we know the measure of angle W is equal to the measure of angle X plus the measure of angle Z, because the exterior angle of a triangle, exterior, that means angle, that means triangle. You can make a nice pointy triangle right there. Is equal to the sum of the interior angles. We can then say that the measure of angle X must be equal to the measure of angle Y, because they are vertical angles, again giving a reason for everything we say. And therefore we can do a nice little substitution and say, well, if angle X is the same as angle Y, we might as well swap it out. That in turn allows us to prove our point. We're going to continue to explore these proofs in pairs together as we continue. Take your time. These are the essays of mathematics. I'll see you in class.